Alright, kiddos, welcome to your more formal introduction to piecewise functions. The class lesson as planned didn't go that well, so this is mostly meant for my 8A classes who did not get the best lesson out of this, and then any of my other kids who weren't here or just struggled with the material in general and need to see it again. So starting with the warm-up, we started with reviewing f of x. So something that's important to remember or to know if you haven't ever learned it, so remembering wouldn't be a thing you would do with it. F of x is the same thing as y. So when we have f of x here, this is y, which means this is also y. So this f of x equals negative 3x plus 5 is similar to saying what is x when y equals negative 4. So, whoops. Sorry, I got interrupted for a second there. So this is the same as saying that negative 4 equals negative 3x plus 5. So we solve whenever we have f of x equals a number. So subtract 5 from both sides. So negative 9 equals 3x, negative 3x. Divide by negative 3, and we end up with x equals a positive 3. The difference with what we have here and evaluate f of 2, so that's what I'm referring to there, f of 2, if you can't understand me verbally that well. There is something in place of the x this time, so we're also going to put it in place in the equation. So if I have f of 2, that means I'm going to write negative 3, and instead of the x, I'm going to put 2 this time, and then I have plus 5. Then I just evaluate. Negative 3 times 2 is negative 6 plus 5, which is negative 1. So that was the warm-up. We had several people not remembering function notation, so we're going to do a lot more warm-ups that have that in it. Getting into piecewise function, we did a little activity to describe the graph. This was the graph that they had. So what I had you do was what you need to do is to add arrows to the ends here and find the equation as well as the domain for each part of these. Whenever I have a straight horizontal line, my equation is simply y equals the number that it's on. This y value is 3, so that equation is y equals 3. For the second one, this line right here, my equation, I need to find the slope using points that cross at the grid line. My slope goes down 2 and over 3 has a y-intercept at positive 4, so my equation there, y equals negative 2 over 3 x plus 4. And these can be in both linear or point slope form or slope intercept form. Sorry, long day. Anyway, the last one has a slope of 1 over 1, or just a slope of 1. And this one I have to go back down at the bottom here to see what my y-intercept would have been. So my y-intercept would have been negative 4. So this one is y equals 1x minus 4. I can also write that as just x minus 4. So I'm going to shrink this down and show you how we're going to use that to write oh, no, just kidding. We need to do the domains now. So the domain for the first one, what I want to look at first actually is what my boundary lines are. And that means when does it change from one equation to another? Or if it doesn't change on that one, where does one stop or start? I have two boundary lines on this one. So for the first one, for my y equals 3, because my arrow is going out to the left, that is all my x's being less than or equal to this value right here, negative 6. So the or equal to, the line underneath right here, has to do with this being a filled in circle. On the second one, I go from -6 is less than x, which is less than my boundary line over here, which is +2. Those are both open-ended, open circles on the ends, so that's why I don't have a line for the or equal to. My last one starts at 2, goes out to infinity. So starting at 2, going out to infinity with that arrow over there. So this one, this one's domain is x is greater than 2, greater than or equal to 2. I can also flip that around if I want to keep everything in less than form. So I can make that less than or equal to 2. Except that I would need an x and not a 2. 2 is less than or equal to x. Now, that's what I'm going to use to write my piecewise function. So the piecewise function is going to start with, I need to get my right color here. So f of x equals, I need a bracket, and then I'm going to put each of my equations in without the y equals. So what goes here? Equations without y equals. So I have the equation y equals 3, the equation y equals -2/3 x plus 4, and I have the equation x minus 4. So those are my equation parts. The next part I need is my domain restriction. So then the first one for the y equals 3 was x is less than or equal to -6. The next one is -6 is less than x, which is less than 2. And the last one is x is greater than or equal to 2. There's a couple things we might see separating this. We might just see a gap down the middle right here to indicate the difference between my equations and my domains. Otherwise, we might see a comma after the equations. I don't really prefer that method, but a lot of them do write it that way. And then you might also see it written as 3 if x is less than or equal to -6, or that's the equation for that domain. So you might see those as well. So that's a piecewise function. The equation, the domain, and your f of x. So to do a couple of example problems, one of the things I recommend is putting in your boundary point first. You're going to find that with your, right here. Those are your, on both of these, that's your domain restriction. That's where you're going to find your boundary points. Careful not to confuse your boundaries and your domain restrictions with your equations, because people try to kind of smush those together and they don't need to be smushed. So I'm going to start by putting in that boundary here, and on number 2 I'll put in that boundary over here, and actually I'm going to zoom in on number 1. Alright, so I have 2 equations here. The top one, which is this part right here, is basically another way of writing y equals -x. To graph that, I have a slope of -1 with a y-intercept of 0. It's another way to write it. So y-intercept at 0, go down 1 and over 1, stop at my boundary. That's one way to go about it. There's other ways that involve erasing. And then I want to keep everything less than or equal to 2, so I'm going to the left. I'm drawing a very not straight line. That's going to be a closed circle because of the or equal to line here. And then that's my first one, so I'm done with that one. The next one is this part right here. F of x equals x. Another way to put that is y equals x, also 1x plus 0. So again, we have a y-intercept here of 0, and we're going to go up 1 and over 1 this time. But the only part of the line that I'm going to keep is the part where x is greater than 2. So I'm going to put an open circle here at 2, continue this out, and then I'm going to go ahead and erase my green there. And put the blue back. So that's the piecewise function on number 1. I'm going to scooch this over for number 2. Number 2, you might note that in our equations, we have no x's. A lot of people want to take these x's, the ones for the domain, and apply it, but you might notice that the commas are sitting there, so that is going to tell us that this right here is the equation, comma, then the domain. So don't try to smush them into each other. So remember, anytime we have an equation that's y equals 2, or this one, y equals -5, and I have no x's, that's a flat horizontal line. So the first one, and this method is just erasing y equals 2. I'm going to go straight across, y equals -5, and it goes straight across at -5. But obviously I can't have two of the equations occurring in the same section. So I've got this section here, and I have 2 equations in it. I can't have that. So I need to erase. The y equals 2 has an x value, a domain of x is greater than -3, which means I don't need anything on the left side. My y equals -5 is x is less than -3, so I don't need everything above that. So then all I need to do is add in my open circles for both, because both of them are just greater than. Put my arrows on the ends, and that's my piecewise function for number 2. We did those 2 together as a class. I'm going to jump to number 9, and that's the last one I'm going to do with you. All right. So zooming in on number 9. One thing I want you to change on number 9 is to take away that negative on that right there. That needs to go. So take that off. You'll just have to scribble it out. So I'm going to start by putting in my boundaries. I've got a boundary at -2. And I have a boundary at +2. So that's all my domain. My equations, I'm going to go ahead and put a little line between my equations and my domain. So my first equation, -x minus 4, is going to start at -4. It's going to go down 1 and over 1. And I'm also going to go backwards because the domain on that is x is less than -2. So that means that I am going to keep everything in this section for that graph. So I'm going to make an open circle right there, and I'm going to draw my line going that way. There's a way to undo my highlighting, so bear with me on that. Next part, I'm going to do in green. That's going to be all in this middle section. So that one is -1/2 x. So I'm going to start it at 0, go down 1 and over 2, and then to backfill, go back 1 and or back 2 and up 1. I'm going to have closed circles on both of those and a line connecting them. And on the very last one, this is again a straight, hang on. This one is just a horizontal line. This is only going to occur in this section. So that being 1 I'm going to put an open circle here because of that right there, and that's going to go out to the right. So something to notice is that when you are looking at this, we have these different sections in blue, in green, and in red, and the graphs each only exist in one of those sections. You can't have more than one graph in any of those given sections, otherwise it's not a function. So that is that, kind of hopefully some